Welcome everyone. Welcome to the live session. Congratulations everyone. You have reached till the day 12. Sorry, day 14. Day 12 I'm saying. Day 14 it is. Coding. Hello sir. Hello brother. Welcome. Welcome to the stream. Everyone just quickly join. We are live now. Hello, hello, hello. Welcome. Welcome everyone. How was your day guys? Or for many of you, how the day is going guys? Good sir. What about you? I am also good, brother. So in the last class, I guess we have seen till the name tuples. No, no, named groups, not named tuples. Okay. So I guess enough people have joined, and today is Friday Eve. So I guess less people will be there. Okay. So let's do what? Let's just start the session. Okay. And okay. So hello guys, welcome back to the channel and welcome to this August Python Bootcamp, which is the 15-day series of learning Python from very basics to advanced. And today is the day 14. So we have successfully completed 13 days. Today we are on the 14th day, and today's topic is multi-threading, multiprocessing, and and asynchronization operations. So we are going to see each and every concept in full detail. Okay, so let's do what? Let's start the session. Before starting the session, means um, before starting the topic, I like to introduce you to one thing. Okay, and then the solution of that thing will be the today's topic. Imagine, guys, imagine you own a restaurant. Okay, imagine you own a restaurant. Now in that restaurant, guys, what happens? Suppose you have an employee. Okay, so if you have an employee, so one employee will take the order, then prepare the food, serve the food, collect the payment, and clean the table. Okay, so in this approach, suppose if you have a restaurant, in that restaurant, guys, first of all, you have one employee. Now that employee has to take the order. Then the same employee will take prepare. Suppose if this is the scenario, prepare the food, then serve the food to the, then collect the payment also, and then he has to clean the table also. So in this approach, what happens is that one employee is engaged for one particular customer. So he will take the order, prepare the food, then if he will clean the table, then only it's different customer will come and sit. Spyro, hello sir, good evening. Good evening, brother. So then only the third person can come and sit and enjoy, okay, and have something to eat. Now the scenario is that everything happens one after another. Okay. Now imagine if you have multiple employees. Imagine now you have multiple employees. So when we have multiple employee, guys, then what we can do is employee one, we will fix employee one. Okay. We will give the work to employee one, that employee one is going to only take the orders. Okay. Then to employee two, will again fix a task. That employee two will do what? He will prepare the food. Okay. He will prepare the food. Then we'll do what? There will be one more employee three, and we'll fix him to serve the food. Now he will only serve the food. And then there will be employee four, that will do what? That will collect the payment. Okay. And then there will be one more employee that will clean the table. So now in this scenario where I have multiple employees, so I can assign multiple tasks, okay, to different employees. That will do what? That will make progress without waiting for one task to finish. If I have one employee, so he will take the order. Then if he is completed with taking order, then he is go and prepare the food. When he'll go and prepare the food, then he'll serve the food. So everything is waiting for the previous task. Okay. But with multiple employees, we are not waiting for, okay, one task to get finished. We are continuously taking order, we are continuously prepare food, we are continuously serving the order, and we are continuously collecting the payment. Okay. So this is the basic motivation behind one context which is called as concurrency and parallelism. Okay, so today we will talk about, the whole topic is related to concurrency and parallelism. Okay, so what is we are going to talk about? And in this context only, everything will come. Okay, so in concurrency and parallelism only, all the concept will come: threading, multiprocessing, multi-threading, and asynchronization operation. Everything comes in this category only. Okay, that is concurrency and parallelism. So now, guys, what is concurrency and what is parallelism? Let's just understand that. So let's first start with concurrency. Now, guys, concurrency, okay, means that you have multiple tasks. Okay, you have multiple tasks, and all the multiple tasks progress during overlapping periods. That is called as Abdul Malik Muhammad. Good afternoon. Good afternoon, brother. Actually, in my time zone, it is good evening. So, yeah. So, guys, in concurrency, what happens? No, that multiple tasks make progress during overlapping periods. Okay, during overlapping periods. So, that is what concurrency is. Whereas parallelism is, in parallelism, what happens? That multiple tasks actually execute at the same time. Okay, they can be executed at the same time. So we can say that concurrency is that we are dealing with multiple tasks. Okay, parallelism is that doing multiple tasks at the same time. At the same time, you are able to do two different tasks. Okay, so suppose I am talking on call and simultaneously I am doing chatting also. So that is what? That is parallelism. That I'm talking on call with a different person and I'm chatting with different person. So that is what called as parallelism. Spyro, shortly revise and start new day. I think it's good. I didn't get you, brother. Now, should I revise the previous day 13 content or what? Okay, so that is what concurrency and parallelism means. Now, using these two concepts, there is a concept which is called as threads. Okay, now those who are not getting my point, okay, have patience. Everything will come at one place. Okay, don't worry. Everything will come at one place and we'll understand everything. Okay, but at first you feel that it is very hard, but then simultaneously it will become very easy. Okay, so let's just give it a time. Now, guys, uh, a thread is like a what is a thread now? Okay, when we talk about a thread, so what is a thread? So thread is like, guys, you can imagine a thread like a worker, like a separate worker inside a program. Suppose if you have a program, now in a program there are multiple workers who work for that program. Okay, so thread is one program, one worker it is. So in a program there are multiple workers, thread is one worker. Okay, so what is thread? So a thread is, so thread is like a worker inside a program. Okay, and what is a program? So program is a set of instructions. Program are set of instructions. Okay, so set of instructions are called as program, and in that program there are multiple workers. Suppose, so one worker, a thread is like a worker inside the program. Okay, suppose I'll give you one more example. Suppose you have to download file. Suppose you have to download files. Okay, you have to download file A, you have to download file B, you have to download file C. So there are three files which you have to download: file A, file B, and file C. So instead of making the program wait for A before starting B, okay, what we can do is we can use multiple threads. Okay, so multiple, when we'll use multiple threads, so we can do that we can say that one thread will download A, one thread will download B, and one thread will download C. So multiple threads can handle these waiting heavy tasks concurrently. Okay, so we can assign multiple threads for this multiple task concurrently, that we can do it, that is possible. Okay, so what is the definition of a thread? So for a definition of thread, you can say that a thread is a lightweight, WEIGHT, lightweight unit of execution within a process. Execution within a process. Okay, and a process can contain multiple threads. That is also one thing, that a single process can contain multiple threads. That is also one thing which you can do it. Okay, so one process can have one process can have suppose thread 1, then it can have thread 2. Okay, and simultaneously it can have thread 3 also. Okay, so one process can have multiple threads. Now take the example of downloading 3 files. Take the example of, if I have to download 3 files. Okay, so what we can do, one approach is that first I'll download A file, then when the file A is downloaded, then I'll download the B file. When the file B is downloaded, then I'll download the C file. Okay, so one is the sequential approach, that one file is completed, then again download another file, then another file is downloaded, then download another file. That is sequential approach. Then one approach is using thread. Okay, so I can assign 3 threads to this 3 downloading, so they all can download at the same time. That is what one thing which we can do it. Beauty's help. Good evening, sir. Good evening. Hello. Welcome to the stream. So that is one thing which we can do. Okay. So now let's just see that how we can create a thread. Okay. So let's see that how we can create a thread. So let's see that. So to create a thread, there is a library which is called as threading. Okay. So you have to import threading for that. There is a built-in module. Okay. There is a built-in module called as threading. You need to import that. Okay, when you'll import that, so let's just first of all keep a function with us. Okay, so I'll keep my function like task, and I'll just give a simple task to print. Okay, so I'll say a task is running, just a single message. Now this is my function, or this will be my task. This will be my function, this will be my task, and then now we have to create a thread. So to create a thread, create an object of thread. Okay, use threading dot thread. So in the threading module, there is a class called as thread. Okay, in that, set the target and give your function name. Assign the task. Okay, now you have assigned the task, so you can say thread dot start. Okay, then what you can say, thread dot join. Okay, and after that you can say print program finished. Okay, so you can give a message when it is completed, it will show you program finished. So task is running, program finished. So what is this thread? Okay, this thread is basically, it is a class present in the threading module, and we are creating a thread object of that. Okay, and using this object, we will start our thread. Okay, using the start function, which is present, which is a method of the object. Okay, of this thread class. So we can apply this only with the thread object. Thread dot start. So it means it actually starts the thread. Then you have join. Join does what? Okay. Start means it actually starts the thread. Join means it tells the current thread to wait until the thread is finishes. So join tells the current thread that wait until the thread is not finished. Okay? Until the thread is not finished. So it means that. Salem, Salem, my friend. Okay, guys. Now let me show you one more example. Now here we are only using single cell. Okay, I've just shown you that how you can create a single cell here. Okay, in this example, we are just learning that how we can create a single thread. Now, what if you have to create a multi-thread? Then what you're going to do? So when you have to create a multi-thread, so now let's see the program for creating a multi-thread. Okay. I have a very good example. Okay. I'll do what? I'll start by importing threading. Now, once I have imported it, I don't need to import it again, but I'm just showing you that how you have to do it. Okay. Now, guys, you'll see that we will create a program in which we will have two functions. Okay. One function will do what? One function will say processing order. Okay. And one function will say means then simultaneously when one function means one order is processed, it will say order completed, like that kind of message. Okay. So that we want to do. So what we'll do, we'll create a function called as process order. Okay. And this will take a order ID as a parameter. Okay. Now I'll just print a simple message that I'll say processing order. Okay. And I'll give my order ID. Then what I'll do, I'll just give a time dot sleep of 2 seconds. Okay. That after 2 seconds, it will again print a message. Okay. And the message it will print. Wait, until the program is not finished, I don't understand the English used here. User, please. Brother, see this example. Okay. See this example, then it will be more clear. And let me just print order ID. Okay. Now this is my task. Okay. This is my task. And now what I have to do, I have to create threads. So I'll just create a list here of threads. And now I need a orders list also. So I'll create a orders list and I'll give you a few lists 102, 103, 104. Okay, like this. I have few order IDs which I have stored in my orders list. Okay, I'll say what for order in orders. Okay, for each order element means for each order ID 101, 102, what I'm going to do, I'm going to create a thread. Okay, so for each order ID, I'll create a thread. Okay, uh, threading dot thread. In this, I'll give the target. Target is process order. So I'll give process order. This is my task. Okay, this is what I'm going to do. And I'll pass my argument. So argument is my orders. Okay, each order. each order here, it will get in an argument, and it should be a tuple of single elements. So I need to give a comma. Okay, I need to give a comma. Now I'll do what? I'll come out of it, and then I'll say, I'll not come out of it. Inside that only, now I have to say, okay, I'll say threads dot append. Threads dot append. This is my in my threads list. I'll say threads dot append and append my thread. And then I'll say thread dot start. Okay, I'll call the start method. Okay. Now what I am doing here is basically I am storing my each single thread which I'm creating in my threads list. And then the single thread which I'm creating here, that I'm starting also. Okay, inside the loop. Now I'll go out of the loop, and then I'll do what? Now I will start my thread, okay, iteration on my threads list now here. And then I'll just simply say that now whatever the threads which we have collected, okay, whatever the threads which we have collected in our threads list, okay, first of all, we are creating the thread for each order ID. Okay. So for that, we have created a loop for order in orders. We are creating the thread, we are passing the function, and we are giving each order ID. Okay. So I'm iterating over the orders. So current current element will be referred by order. So I'm passing that order. Then I'm starting the threads. Okay. In my threads list which I've created, I'm appending my thread which I am creating. And the thread which I have append there, that I'm starting also. But starting is not enough. I have to use join also, because join is used to tell us that wait for the task to be completed. Okay. So for that, this join is used. Now to execute each thread which we are storing in iThreads list, again we are starting a loop. Now this time we are starting the loops on our threads list for each thread. So this is the loop variable, and this will tell us about the current element, the current thread. Okay. And on the current thread, we are saying join. Why we are saying join? Because we want to wait for the previous thread to be completed. And then I'll say print, and at last I give a message that all orders processed. And let me just execute this. Okay. Now you see one thing. Let me just execute it again, and let's just see the output. Okay. Let's see the output. You get the output together. Okay. Processing order 101 means 101, 102, order 1, 2, 3, 4, 101, 102, 103, 104 started processing together, completed the order together, and all orders processed, we get it at once. So this is what threading means, that we can simultaneously do multiple tasks. Okay, so the exact order of the message can vary, but you will typically, okay, I should do what? I should give extra print over here, so that now you'll see you get processing order, then after 2 seconds you will get completed. So all the orders 101, 102, 103, 104, they all are getting completed. Okay. So this is why multi-threading is important, that all the four threads, okay, because total, how many order IDs were there? Four orders were there. So for total four order IDs were there. So how many threads were created? For each order, one thread was created. So for four order, four threads were created. And all the four threads can be waiting or working concurrently. Okay. So because of that, processing order together and order completed also together. Okay. Now let me show you one more example. Okay. Now, if I'll not use thread, and if I'll execute this task, so this task will, there are how many? Four orders were there. So each task will take 2 seconds. So four tasks will take 8 seconds. But with threads, in 2 seconds only, all the four tasks are completed. Are you getting my point? What I'm trying to say? Okay. If I'll write the same thing, if I'll try to do the same thing without thread, so it will take about 8 seconds. Why 8 seconds? Because first it will do the first task. for first order ID. Then it will do the same task for second order ID. And each task is taking 2 seconds. So 4 tasks will take 8 seconds. But the same thing for using thread, the same thing, okay, we are doing it, okay, with the help of the threads, we are doing it in 2 seconds, approximately in 2 seconds, okay. So that is what all the 4 orders start processing around the same time. Are you getting my point? Okay, okay. Sir, please retake explanation. Okay, okay. Let me just go back. Let me just go back. First of all, guys, understand this concept of thread. Okay, thread basically means, first of all, don't go that also. Suppose think of a program. What is a program? Program is the collection of lines of code. Am I right? And Python follows line by line execution. So first line will be executed, then second line will be executed. Sir, sleep you gave, that's what's the use here? Ma'am, that is used to sleep your program for 2 seconds. So sleep is used to pause your program, pause the execution of the program, and the number you write, like you written 2, it means for 2 seconds your program will be paused. If you write 1 second, so if you write 1, so it will be paused for 1 second. Okay, guys, understand the concept of thread. I'm again explaining it. You have a process, okay? You have a process. So process is what? Process is the set of, it is a set of execute, means not execution, what you say? A process is set of, uh, what is the smallest unit that is called as instructions, set of instructions. Process is, understand this concept, okay? I'm again explaining it. Process. First understand process. Process is set of set of execution. Okay, actually sets of execution. It means multiple things are there in one process. So in one process there are multiple things. So thread is a lightweight unit of execution. Okay, process is a set of execution, thread is the lightweight unit of execution. So one process has multiple execution. Okay, and in one execution, for executing a one task, thread is the light light lightweight unit. What do you mean by this? When I say thread is a lightweight unit of execution, it means that to measure one execution, okay, using thread we can do that. Okay, to measure one execution we can use thread. So we can do what? We can assign one execution to one thread. Understand in this way, that you can assign one execution to one thread. Okay, and multiple executions together form a process. Okay, forms a process. Remember that. Okay, let's now do what? I have an example, and you can create multiple threads. So of one process, of a single process, you can create multiple threads. So why you need to create multiple threads? You need to create multiple threads because process is a collection of, or it is a set of executions, it is a set of instructions. Okay, now to, or for all that instructions you can create a separate thread. Okay, why you need to create separate threads for all the instructions, for all the executions? Because to save time. Otherwise, now come here, suppose if you have to download three different files, if you have to download, suppose there is a file A, then there is file B, and then there is file C, and you have to download all these files. So what you can do, you will start downloading the A file. Then once A file is downloaded, then you will download the B file. Then once it is downloaded, it will download the C file. Okay, or now what you can do is, instead, now in this, suppose A file is taking 2 seconds, A file is taking 2 seconds to download, and B is also taking 2 seconds to download. And same goes to C. Same goes to C. C also takes 2 seconds to download. So now if I'll download A file and I'll wait for A file to be downloaded, then I'll download the B file. So that how many time it will take to download 3 files? Total 6 seconds. So total 6 seconds will be taken to download 3 files. Okay. Now same example. Okay. Same example, you can take it now using threads. Using threads, what you can do, you can assign, you can create thread one. Okay. And you will say to this thread one that I'm assigning the download a file to thread one, and simultaneously, okay, I'll create one more thread two, and I'll assign download thread b download b file, and then in thread three I'll assign this. So now what will happen, guys? These three threads, thread one, thread two, thread three, they will download each file, and they will start downloading at the same time. Understand that concept. They will start downloading at the same time. So total how many time will be taken? If this takes 2, this also takes 2, and this also takes 2 seconds, 2 seconds, and this also takes 2 seconds. So now using threads, total time taken will be 2 seconds only. Okay. Why 2 seconds? Because A file is also downloading at the same time, B is also downloading at the same time, and C is also downloading at the same time only. Now, to download B file, I don't need to wait for the A file to be completed. Okay, I can download all these 3 files at the same time. Understand the concept. You can download all these 3 files at the same time only. So each file will take 2 seconds. So in the same 2 seconds, I can download three different files. So here the total time taken is 2 seconds. And here the total time taken is 6 seconds. Okay. So that is what threads give you. That is what threads give you. And the same thing, now here in this program, I have shown you that how you can create a thread. Okay. In this program, I have shown you that how you can create a single thread. In this program, I have shown you that how you can create multi-threads together. Okay. So I have done what? First of all, to create a thread, there is a built-in module in Python that is name is threading. Okay. Okay. Then I've used the time module because I wanted to pause my execution in between. Let me show you where here I'm using it. So I've created I've created a program. Now this program is for orders. Okay, suppose I have a list of orders, and for each order I have to process the order, and then I have to say that order is completed. So this simple task I have to do it, but I don't want to do like in this way, that first the first task will be done, then the second task will be done, then the third task, then the fourth task will be done. I don't want to do it in that way. I want to do it in one way only, directly. Okay, means I wanted to save my time. So what I did, instead of using a direct loop and directly doing it, I created 4 threads. Okay, or not 4 threads, because there are 4 IDs, there are 4 orders, so because of that 4 threads. Okay, if there are 5 IDs, so 5 threads. If 6 IDs, so 6 thread. And here what is happening, I've created a function. In that function, I'm just printing that processing order, and then I'm just sleeping. I'm just taking a pause of 2 seconds. That after the order is processed, pause the program for 2 seconds and then print order is completed. When you, in general life also, when you process order, it take times in processing, no? Okay. So just to depict that in programming, I'm just pausing my program. It's just for that purpose. Okay. Then what I have done, I have created a thread list. Okay. In that thread list, what I'm doing, I'm storing all my threads one by one. Okay. Why I'm storing it, I'll tell you. Okay. Then I have my order list in which I have my all orders. Then I'm using my loop on my orders list. Okay. Because I have to create threads, but how many threads I have to create it? So I have to create threads that much IDs are there. So if 4 IDs are there, so 4 thread, 5 IDs are there, so 5 threads. So that's why I'm starting the loop on my orders. So I'm saying for order in orders, my orders list, I am creating a thread, okay, using the threading module and the thread class. And in target, I'm giving my process, this function, okay. Target means give the task. I'm giving my task. My task is the function process order. I'm giving the task and I'm passing the argument. Argument is what? The current order, okay. So it will create a thread for 101, ID 101, okay, because process order takes one parameter. So that parameter will is this order is the parameter which will be given in process order. And this is how you do it. This is how you do it. Okay. Then what I'm doing, I have my threads list. Okay. So the thread which I'm creating it, that thread I am adding it my thread list. Okay. And I'm using append. So each thread will be added in the end of the list. Okay. And then I have shown you in this example that once you have created a thread, to execute that thread, you need to start the thread. So that's why I am saying here thread dot start. I'm starting the thread. Okay. Then I've given a blank space so that a space should come here. Okay. So this space is for that purpose. Then I'm again starting a loop, a different loop. Why different loop? Because now my all threads are stored in this thread list. Okay. So till now my threads are not being executed. They are just only started. Okay. So then what I have to do? I have to say to my thread that please wait for, okay, all the threads to be completed. Okay. So for that join is used. Join says that join tells us that wait for the previous threads for them also to be completed. Okay. So that is join. Join tells us current thread to wait until the all threads are finished. All threads are finished. Okay. Okay. Now, and then I'm just simply saying print all order processed. Okay. So using this, when I'm executing my program, you will see that all threads are started processing order at the same time. And after 2 seconds, we are getting the message that all the orders are completed. Okay. So this is why we are doing it. This is why we are using threads. If you will not use thread, if without thread, if I'll do the same program, so it will take total 8 seconds. Okay, but with thread it only does all the four tasks, means for all the four orders, it processing the order and completing the order within the span of 2 seconds only. So in 2 seconds only my all four orders are processed. Okay, means processed together, and in 2 seconds order is completed also. But if I'll not use thread, so they each order will take 2 seconds. So four orders will take 8 seconds. Are you getting my point? What I'm trying to say? So this is the meaning of, this is why threads are used. This is why threads are used. Okay. Yeah, that's the thing here. Okay. So that is a simple way. That is the simple thing. That is what threads are. Okay. And this is how you can create an multiple threads. This is a simple program. Okay. You can use it for all the other tasks also. Are you getting my point, guys? Okay, sir. Got it. Clear now. Okay. Okay. Good. 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 Okay. Good. Got Abdul Malik Mohammed. Got it. Okay. 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 That's very nice. That's very nice. Okay. Okay, guys, now the next topic is, okay, in this only, there is the next topic. Okay, now in this, there is a problem also. Okay, in the threading, there is, means problem can happen, and that problem name is called as race condition. Okay, so race condition is a kind of problem that can occur. Okay, I'll give you an example of race condition, then it will be more clear to you. Let me just understand you. Suppose, guys, okay, suppose suppose you and your parents, or you or your spouse, are sharing the same bank account. Okay, it happens, no, that husband wife or the spouse, they together create a bank account, so they are both partners in the same account. Or parents do that, father, mother, and children, they together create a bank account, they share the same bank account. Okay, so just imagine that two people share a same bank account. Okay, and in that bank account, the balance is, let's say 1,000 rupees. Okay, so two people are sharing the same bank account, and the balance is 1,000. Now what happens? Okay, now what happens? um Scenario is something like this, that person A withdraws 700. Oh, my bad, why it's writing here. Person A withdraws 700, and person B also withdraws 700. Is it possible? You tell me. In a bank account, is it possible that your balance is 1,000 rupees and two people are sharing the same bank account? So if person A withdraws 700, so then the balance should be updated, no? If will not update the balance, and suppose uh, person A lives in different city and B lives in different city, and they both are not telling each other, they, person A is withdrawing the money 700 and B also withdrawing the money 700. So who will get that money? Okay, because both cannot withdraw 700. No, if one can withdraw, another will not be able to withdraw, because balance should be updated. So this concept happens with coding. No error. Yes, yes, I know, both cannot withdraw, I know. Yeah, so that is the thing, no, that is the thing, that if both operations read old balance, if the both means this operation and this operation, both the operations will read 1,000 only. So before either writes and update the balance, both might believe that enough money is there. Okay, both will believe, means if person A is has withdrawn 700 and B does not knows it, and balance is not updated, and before updating the balance, if B also tries to withdraw, so B will also feel, no, that it money there are 1,000 rupees, so B will also try to withdraw 700. Okay, so that is what I'm trying to say, that if both operations read the old balance, before either of the operations update the balance, so both might believe that there is enough money exist. So this kind of scenario is called as, that's called as race condition. This kind of scenarios are called as, this kind of problems are called as race condition. Are you getting my point? So this is what race condition is. Okay, so simple definition, if I have to write a simple definition of a race condition, so that a race condition I can say that a race condition occurs when multiple threads, or you can say multiple processes, okay, try to access try to access a shared state. What is a shared state? Shared state means shared data, shared file, okay, that kind of thing, shared values. Okay, so shared state concurrently. Okay, concurrently, and the final result depends on the timing. Okay, so now the final result depends directly on the, okay, let me just put it, huh? So final results depends on the timing or timing or order, timing or order of execution. Okay. So actually it is inaccurate. No, you guys tell me that now it totally depends on the timing. If A will withdraw, so B will be not able to withdraw. If B withdraws, so A will be not able to withdraw. So the fraction of seconds will also matter, that whose values is getting updated first. Okay, so that's what I'm saying, that a race condition occurs when multiple threads or processes try to access the same shared state concurrently. That suppose thread 1 is accessing it, thread 2 is also accessing the same thing, thread 4 is also accessing the same thing. Okay, same state. Okay, so the final results actually depend on the timing and the order of execution. Okay, I have a very beautiful programming example for this. So let me show you that example. So I have already imported threading, so I'm not going to import it every time. Okay, so I'll create a counter and I'll initialize it to 0. Now I'll do what? I'll say def. Okay, I'll create a function to increment this counter. So I'll say what? Def increment. Okay, and I'll just make this counter as global because I'm going to change this counter. Okay, so I'll make it global. Why I'm making it global? Because I'm going to continuously increase the counter again and again using a loop. So I'll say for underscore in range, let me give a range. Okay, counter plus equals to 1. Okay, let me give a less value only. Okay, now this is my function. Then I'll create two threads. I'll create T1 and I'll say threading, oh, threading dot thread target, target increment. Then I'll create again one more thread called as T2. Okay, then I'll do what? I'll start T1 dot start. Then I'll say T2 dot start. I'm starting both the threads. Okay, then I'll say uh, T1 dot join, and then I'll say T2 dot join. Okay, and at last I'll do what? I'll print my counter. At last I'll print my counter. Let's execute this. Okay, see, you are getting 20 here. Now why we are getting 20? Okay, because here is it is 10. So I'll do what? Let me just make it a very big number. So see what happens here. Okay, you can see the output. Okay, so don't assume that a shared read modify write operation is automatically safe just because it looks like in Python one line of code. Okay, so it totally depends on the interpreter version exact code. Okay, that is how you do it. Now why we are getting this output, anyone can tell me? What is this underscore? This underscore is that it is the loop variable only which will denote the current means it is a loop variable only, but I don't want to give a variable name, so I've just directly given an underscore. Okay, so it's just that I'm just skipping this part because there is no role play of a loop variable, no, because I'm directly just incrementing my counter. Okay, so it's just that. So if I'm getting a million value, suppose I'm getting 10 here, when I'm giving 10 I'm getting 20. So why, how it is happening, anyone can tell me? It keeps by default the result of the last operation. Okay. So the simple reason is, guys, that you have two threads. Okay, you have two threads. So what is happening is that thread 1, okay, incrementing the counter 10 times. Thread 1 is increment because our range is still 10 only, no? So thread 1 is incrementing the counter 10 times and thread 2 also incrementing the counter 10 times. So therefore mathematically Mathematically, what is happening? Thread 1 plus thread 2. So 10 plus 10, 20. So that's why we are getting 20 here. Okay. So that is what I'm trying to say. Without camera, I didn't understand because the two threads executed at the same time. Yes, yes, they are executing at the same time. That is the okay. That what threads do. That's what thread do. That is not the reason here. Without camera, I didn't understand. Okay, okay. Now you're saying you got it. Okay, okay. Spyro counter plus equals to one, not equals to plus one with 12. Okay, okay. No, no, it's not like that. Okay, I guess you guys have not understood. I'll again explain it. See, guys, what's happening here is basically in simple ways that both the threads are using the same counter variable. Now you got it. The problem which we have told you, race condition is happening here. Race condition is happening here. Because of that, we are getting the output as 20. Both the threads are updating the same counter. So suppose T1 updates is to 10. So T2 is also updating after 10. Same shared state is being used. Okay. That is called as race condition. So that we don't want it. Now suppose you guys want to book a ticket, a flight ticket or a railway ticket, okay, and one ticket is available and two persons are together trying to book the ticket. Who will get the ticket? Who will get the ticket? So again the race condition will come based on the timing, based on the order of execution, the race condition will come. Okay, suppose like the banking example, two withdrawals are happening at the simultaneously, okay, same time. So then again the race condition will come. Okay, two different file means two persons are there, two developers are there, and both the developers want to write to the same file. So whose content will be written first? That is what called as a race condition. Without camera, what you are saying, brother? Def is executed twice, isn't it? Brother, it will be obviously executed twice because there are two threads. So twice it will be executed, but it is executing twice, but it is using the same counter. No, it is using the same counter. So updating the same counter. So thread 2 is also using the same counter. Thread 1 is also using the same counter. That's why we are getting 20. So that ideally should not be happen. Okay. So then there is a concept called as, for that kind of purposes, there is a concept called as lock. Okay. So there is a concept called as lock to solve the problem related with the race condition. There is a content called as, okay, there is new, okay, that is the next part that is called as lock. So lock will do what? Suppose if multiple people needs to access the same room, suppose if multiple people wants to access the same room, so you can give them a key. Okay, first apply a lock to the room and you can give a key to them. Okay, now you will allow only one person inside at a time. That is what lock gives you. That is what locks give you. So this lock we can apply on our shared data, on our data, which will be shared for all the threads, but you can apply a lock. So applying a lock will do what? Applying a lock will make sure that only one thread at a time can access it. Then other thread will access it. Then next thread will access it. Like that. So that is what I'm trying to. So that is resolved using the lock. Okay, that if you have a file which is a very critical file, okay, you don't want multiple threads to access it, so you can apply a lock on that. Okay, so if the thread has a permission, then only that thread will be able to access it, otherwise the thread will not be able to access it. So that is what we are trying to say. So a lock, if you want the definition of lock, so a lock is a synchronization mechanism. Okay, it is a synchronization mechanism, okay, that ensures only one only one thread at a time can enter a protected section of code. Understood? That is what lock provides us. So now let's see an example. Now let's see an example using lock mechanism. So let's just do that. So let's just write the program. So I'll create a counter again, 0. But this time I'll say lock equals to threading dot lock, capital L. Okay. Then again, the same function. Okay. So rest of the things will try to keep it same. So I'll just copy it. And let me just, little bit changes will be there. Okay. Anyone does not have a question that, sir, same output we are getting, nothing has happened. Okay. Why? Yes, nothing has happened because, guys, we have just created the lock. Only creating the lock is not enough. No, you have to use the lock also. Where you are using the lock, we are not using the lock. No, so we need to use the lock also. Okay, just creating the lock is not necessary. Just like how you create a function. So create a function is not important. Creating a function, then you have to call the function to execute it. No, so when you have created a lock, so you need to use the lock. So how you are going to use the lock? So for using the lock, you will go where? You will go inside your loop where you are incrementing the counter. Yes, you haven't gave in the lock. You just gave example. You haven't gave in lock argument. Yes, yes, yes. Okay. So now, guys, you need to give the lock. But where you will give the lock? Where you are trying to access the counter. This is the line where I am incrementing my counter. So here I'll give the lock. So I'll say with lock. Okay. Yes, I'll use the with statement with lock counter plus equals to. Okay. Now the output is not going to change, but the output is not going to change, but you will still get 20 only. The output is going to be same only. But this time, okay, You have applied the lock on the data, on the counter which you are trying to increment. Okay. So now it is more safer. Now it is more safer. Is the concept clear, guys? If the concept is clear, then we'll move to the next topic. Otherwise, if you want to explain me again, I can explain it. This is the difference, that this time, because we have applied the lock, so one thread is accessing it at one time, then another thread is accessing at one time. Both the threads are not simultaneously accessing it at one time. Okay. Understood, but only lock will keep it away from the rest condition. Yes, using this, first of all, you have to create the log. Okay, there are a few more ways, but this is the advanced way. This is what Python supports. This is called as the context manager, just like how we open a file, how we handle the databases using the with context manager. So using this, what you get a block-like structure. So inside this, you can write it, so it is more safer approach. Okay. If you not use this, then you have to use log.acquire and log.release. Okay. Then you have to acquire. Mulmulan, it's clear now. Okay, okay, okay. It's clear. It's clear. Okay. So let's now go to the next part. Okay, guys, let's just give me 2 minutes. Let me just have water. What Spyro is saying, tomorrow last day or 1 2 day will extend. No, brother, no day will be extended, but we'll come live. We'll come live. I'm trying to I'm trying to work on creating and touching more other topics. Okay, so different kinds of topic, like Flask is going on now. Basics of Flask, we have covered the whole basics part of Flask. Now we are dealing with projects, so there will 1 2 projects will come. One project is going on. The second video will, I think it has uploaded or it will be uploaded just now. Okay, on the project part 2, a student registration system. After that, there is again one more very good project will come in that. Okay, after the Flask, I'm thinking to come up with something interesting related to AI, understand the working of AI and understand how you can create an LLM and everything. If not AI, then we'll come with a data science. Okay. And in the live, I'm thinking to, to come up with a DSA course. Okay. But I guess people are more interested in the basics concept. Okay. I'm watching the Flask. I like it. Thank you so much. Thank you so much. So, but I feel that people means people on YouTube, they like more basics concepts. I feel that. Sir, project part one, you gave one init file was complex to understand. Brother, that init file is just the initialization file, okay? That init file is just an initialization file. I have shown you that init file here in our live sessions. In live sessions, I have explained you that each file automatically gets a init file. Okay, so that file is also like that only. We are just creating an init file that is automatically done. When the file is called, it will automatically be executed. It's just that purpose. Okay, and standard projects now, the in the way I'm creating the project, the student registration system, that is the standard way which is used in industries. There are more easy approaches of in single file I can do everything, but I'm not doing that. I'm creating a standard approach, industry related approach. No, no, please uh don't basic, because basic everyone teaches hard to get advanced concept. Spyro, any further course start from basics that helps a lot? Yes, brother, I'm talking about that only. On that thing only, I'm just thinking that should I come up with a DSA course, okay, where you guys will learn how to create different types of data structures. Now, in Python, there are four data structures, but apart from that, also there are data structures like stack, queue, linked list. Okay, so there are other data structures also. Graph is there. Beauty is help. Don't teach basic. I mean to say. Yes, ma'am, you are correct. But the scene is no that I see um on YouTube, people like the basics parts more. They feel more engaging. Okay, so that's the thing. Means for the advanced topics, no, there are limited number of people, but I cannot cater to the a large number of people. But for the basics, there are very large number of people who wants to do that. So I'm thinking to come up with that. Means again a boot camp or a series like this where I'll start with the basics, okay, and then I'll go towards the advance. So I'm planning to come up with that. And currently I'm focusing on the DSA part only, okay? Because simultaneously I'm recording the videos for Flask, and probably after Flask is over, I'll just continue it for AI. Or if not AI, so then I'll definitely come up with something data science related thing, okay? So maybe that would also come, okay, as the videos. And in the live sessions, I'm planning with come up with DSA, okay, because it's going to help you guys a lot. Beauty self, sir, teach what will be beneficial for jobs. Ma'am, everything is beneficial. Means if Flask, if we talk about Flask, so Flask is also important. Nowadays there is very web frameworks demand. Okay, so there is a demand of Flask also. Data science, machine learning, that you already know it only. The industry is all about that only. So, ma'am, the full Python has demand. Okay, the Python programming language has only demand. Data science or data analyst will be very helpful. Yeah. Okay. Okay, surely. After Flask, I'll try to come up with that. Okay. AI ML with Python automation. Two, it's fine. Yes, that also can we can do it. Okay. We can come live for AI ML along with Python automation. Okay, that is also fine. But the thing is, no, for that I need few advanced tools. Okay, I need few advanced tools or high system configuration should be there. Otherwise, sometime it happens no that in my company system also sometime my company system also get lag or it hangs sometime. Your system needs to be very advanced. Okay, because only Python. No one entertains for jobs. They want everything together. Yeah, that's correct. That's correct. That's correct. Only Python. So Python is not about only Python. No, Python is about when you say that you are a Python developer, means when you say you are a Python developer. So what do you mean by a Python developer? What do you mean when you say Python developer? That if someone asks you, you will say, I am a Python developer. So then what you do? Okay, in industry, a Python developer does what? So in industry, the Python developer, now they are in separate categories. They are in different fields. In developing in Python developer also there are different sectors. No, different sections are there. So this those sections are, first of all, if you are saying you are a Python developer, so you should know the backend. Okay, you should know the backend. Backend is the most important part. One is recorded and one is live. Yes, yes, Spyro. Yes. Okay. So I hope you guys got it. When you say you are a Python developer, no, so companies expect one thing from that you should be able to build backend applications. Python developer means what? That you are able to build backend applications. Okay. Backend application means, suppose front end you can create it using HTML, CSS, React, JavaScript. But how you will create or how you will manage the APIs, how you will manage the backend, the servers, the databases. Okay. So Python developer, when you say Python developer, so company expect that you will build API using Flask or using Fast API or using Django or using Django REST framework. Using any one of the frameworks, you should be able to build the APIs. That is what a Python developer is. And then you say, when you say Python developer, then companies also expect that you should also have a knowledge of the databases like MySQL. Now, MySQL is the compulsory one. You should know MySQL. MySQL is there. Then nowadays, PostgreSQL is there. Nowadays, there are many other applications. Nowadays, there are many other applications like NoSQL databases are there, which has no structure. Like MongoDB is there, Redis is there. So you should be able to work with that also. For practice purpose, there is SQLite, which is directly can be integrated with Python. So Python developer, when you say Python developer, you should be able to do two, three things that is mandatory only. That's why I come up with Flash course. That is the only reason why I come up with the Flash code. Because when you say that you are a Python developer, so it means you should be able to know that how to build a backend. Okay, how to work with applications backend. Okay, so that's the thing. These are the few things which a Python developer might know. Then apart from Python developer, when you say you are a data scientist, or when you are say that you are a data scientist enthusiast or something like that, or you are a data analyst, so then see, if you say data analyst or data science, so these things can be done with other programming languages also. You guys might have heard of the programming language R. Now, R programming language is also used in data science and data analyst. Okay, you can use R programming language also. So when you say you are a data scientist, so then you can use Python for that. But there are other programming languages also which can be used. Possibly you can use other programming languages also. But when you say you are a Python developer, it means you are specific to Python. Okay, so that is the thing. Backend app development. Have Tam had backend app development. Yes. Okay. Backend app development means building the servers, building the APIs, API routes, creating the API routes. I mean that. Okay. Have Tam had. I'll suggest, brother, go and not now. After the session is over, try to see my Flash series. Okay. From that, you will get about this backend application. What are these? Okay, everything. AI or analytics or data science. Yes, Spyro. Yes. Okay. So guys, okay, let's do what? Let's come back to the topic. Okay. And if any problem, any question you guys have, you can ask in the chat and I'm there. I'll reply it. Okay. So now I guess you have understood when you say Python developer. So what are the things which is necessary? Okay, now this concept of threading. Now, when you say Python developer, so this concept of threading also you should understand and you should able to write codes in that. Okay, because you see clearly it's saving the time. Okay, so this is how you do it. Now, guys, I'm going to create a program for ticket booking. So I'm going to create a program for a ticket booking system. Okay, using threading. Using threading, we are going to do that. So I'll do what? First of all, I'll say available seats. Okay, available seats lock equals to, I'll create a lock first. I've created a lock. Then I'll do what? I'll create a function called as book ticket. Okay, called as book ticket, which takes the user, as a parameter. Then I'll do what? I'll say I'll create make this available seats as global because I have to change the available seats simultaneously. I'll start my lock. I'll say with lock. With lock, do what? Then I'll give a condition. The condition is if available seats is greater than 0. If it is greater than 0, so print a message. Print a message that user, okay, user booked the seat. Okay, and then do what? Then in available seats, decrement it by 1. Yeah, decrement it by 1. If the ticket is booked, so then the seat should be 0, no? Then the seat should be decreased. So we are decrementing it, okay? Then in the else, we'll give a message, okay, that if the seat is equal to 0, if the available seat is equal to 0, so then in the print, we'll give a message that user, user, and we'll say no seat available. Okay, we'll see no seat available. Okay, now come out of the function, come out of everything, and let's create two threads here. So I'll say t1 threading dot thread. Okay, I'll say target equals to book ticket. Okay, and in my argument I'll pass. Okay, I have to pass a tuple. Inside that tuple, I'll say Piyush. Okay, one parameter. Then I'll create one more thread and I'll say T2 and let me just give Rahul. Okay, then I'll do what? T1 dot start. Okay, T2 dot start. Then I'll say T1 dot join. Then I'll say T2 dot join. Okay, now guys, let's execute this and let's see what message we are getting. So now you will see Piyush booked the ticket, Piyush booked the seat, and Rahul, no seat available. Okay, you got the, now you see the change in the output. Now the output are not same. So it's just how you write the program. It depends on that. But now you see that one thread, what we are doing, we are applying a lock. Okay. So whatever the first thread is, whatever the thread is getting first here. Okay. So that will do what? That will lock that particular critical section. Okay, so that critical section, now this is the critical section. Critical section means that inside this section there is a available seats, that is my shared data. This is going to be my shared data, or this is going to be my shared state. Now this state or this data is shared. Now to stop that, what I am doing, I'm applying a lock here. So whatever the thread will go first here, that will apply a lock. So this is a critical section. Only one thread at one time can access it. Okay. Then it checks for a condition that if the seat is available, okay, So now you will see that this will be locked. Seat and all this section will be locked. That will be not execute. Only one thread can access it. Two sets simultaneously cannot access it. Okay. Now it will, if it is condition is true, means if it has one seat available, so it will do what? It will book the seat, and it will decrement the seat because seat is booked now. So now there should be no seat, there should be zero, so decrement it by one. Then it will come back. Okay, then again the next thread will go. Now when the next thread will go, next thread will also apply the lock. Next thread will also apply the lock, but this time the condition will be checked and available seat is in means decremented and is equals to zero. So this condition will be false. So then this message is printing. So that's why for Piyush the book seat is booked. For Rahul, because already Piyush has booked and only one seat is was available. So Rahul, no seat available message gets. Okay, is it clear? Okay, okay. There is problems. So, sir, always first thread will get logged, isn't it? So, sir, but nowhere we mentioned there is one seat available, one seat only. Yes, I have mentioned here. How you're saying available seats I have initialized in this variable one. I have initialized one here. Available seats equals to one. So, sir, always first thread will get locked, isn't it? No. It's uh, T1 is not first thread, and T2 is not second thread. I've just given the name. I have just given the name. Okay, just for the clarification that it's not like that that this is the first thread and this is the second thread. It means that this is also a thread. It means this is also a thread, and this is also a thread. There is no priority that this thread is first and this thread is second. It's not like that. Okay, and when I say t1 dot start and when I say t2 dot start, so it doesn't mean I'm saying that first t1 will start and then t2 will start. I'm not saying that. Means Python does not means it does not means that. Okay, what is this with used for? With is used for, it is a context manager. It is a context manager. In this case, it is start to, it is used to start the lock. It is used to start the lock. Lock our critical sections. Okay. Okay, sorry. Uh, sorry. No, ma'am, it's not about sorry. Okay, it's not about sorry. Means we have created it here already. Okay, no need to say sorry. We are learning here. Okay, we are learning here, so no need to say sorry. Okay, and ma'am, you have one more question that uh always that Piyush will get booked. No, it's not like that. Okay, Piyush will not get booked always. Uh, Sometime Rahul, it depends on the CPU. Okay, it depends on the CPU. That CPU is giving time to which thread first. Okay, but it's not compulsory that Piyush will be always booked. Okay, it's not compulsory because here means when I'm executing it again and again, it only says Piyush. Okay, because of maybe it should happen because of the automatic memory management system of Python. It may so happen, but it's not like that. Okay, it's not like that. It's not like that. So understand that part, okay? So that is what this is the use of the lock, okay? This is how you use lock. And this is how lock is used, okay? One more thing is there that this is you use lock and this is how the lock is also used, okay? So I hope this topic is clear. So let's go to the next topic. That will be now the next topic will be, now we have learned multi-threading. So now we'll learn multi-processing. Okay, so now we'll learn multi-processing. So what is multi-processing now? Because we have already seen multiple threads, multi-threading. So till now we have understand one thing, that threading means that there is one process, and inside that one process there are multiple workers, and we can represent each worker by one thread. Okay, so in a process we can have multiple threads. Till now we have understood that. Okay, now in multiprocessing what happens, that you have multiple processes, like you have process 1, you have process 2, you have process 3. So multi-threading was the concept inside a single process. Okay, understand the point. First, guys, I want you to leave every task and just listen to me. What I'm trying to say, that multi-threading was, we were talking about inside a single process. Okay, that was multi-threading. Inside a single process, there are multiple threads which we can create it. Now, multi-processing is that there are multiple process itself. Okay, so multi-processing is particularly, it is useful for CPU bound work. Okay, what do you mean by CPU bound work? CPU bound work means the work, the task which is performed in the CPU. Like here, like in this example, Pius gets the seat and Rahul do not get the seat. So what happens here? CPU is giving the time to the Pius user thread first, okay, and then it's giving the time to the Rahul thread first. So because of that, because of, who is doing that? CPU is doing that. Who is doing that? CPU is doing that. So multiprocessing is particularly, it is a useful CPU bound work, because it separate processes. Okay, it separate processes execute the Python code on different CPU cores. Now in CPU also there are multiple cores. CORES, there are multiple cores. When you go and buy a system, when you go and buy a laptop or a system or a processing unit, so it is written there. When you go and buy a chip, a Intel chip, a AMD Ryzen chip, okay, so it is written that how many cores it has. Okay, so 12 cores is there. Out of 12, 8 are performance cores, 4 are efficient cores, or sometimes there are 16 cores, 8 is efficient core, 8 is performance core. So these types of cores are also there. And the number of cores that your system has, the more number of cores, it means the CPU is more powerful. The CPU can work on lots of things together. So number of cores means you can do multiprocessing. If you have single core, it means you cannot do multiprocessing. So that is what multiprocessing means. Is multiprocessing clear, guys? If it is clear, then only I'll go forward. If it is not clear, I'll again explain it with other examples. So let me know, because it is a very critical topic. Okay, and people get confused in threading and processing. So first of all, understand, if everything is clear, so I'll go forward. Tell me, guys, 11 people are watching. Quickly tell me. Please explain again. Thank you. Okay, okay, okay. Okay. So most of you have not understood. So let's do what? I'll take an example. Guys, in the starting of the live session, yes, it's clear. Yes, sir, please. Okay, okay, okay. One person is not clear. So let me just quickly revise it. Okay, guys, just give me 2 minutes. In the starting of the section, guys, in means the starting of this live session, I have given you an example of the restaurant. You remember the example that if suppose there is a restaurant, so if I have to do a task, so that task can be done by multiple threads. Okay. Now suppose in that example I've given you that there are only one employee fixed with booking to take the tables orders, one employee is fixed with cooking food, one is fixed with serving the food, one is fixed with collecting the payment, one is fixed with cleaning the table. Now suppose if you have 50 customers arrived in your restaurant at the same time, then what you will do? Okay. Now it will, you guys will understand it. Suppose 50 people have arrived at your restaurant at the same time and you have only 5 employees. So, and one employee is fixed with cooking, one employee is fixed with cleaning table, one employee is take with taking order. So again, the same problem will come. No, because in threading we are talking about one process, but now 50 people arrived, it means 50 process. So for 50 processes, what you're going to do? So then the concept of multiprocessing come, that what you will do now, that you can keep 5 chefs, you can keep 5 people for taking the order, you can keep 5 people for cleaning the table, you can keep 5 people for collecting the payment. Okay. So this will do what? This will make the task do it in more less time, in less time and more easily. Because if you'll not do that, so one chef is there and 50 orders are there. Okay. One employee is there and he has to take the order from all the 50 people. So suppose if you'll take the order from the first people and then you will take the order from the second people, and in each person, in taking the order he has to invest 2 minutes. So till the moment he reached to the 50th person, he has already taken 1.5 hours, 1 hour and 40 minutes. So that 50th person, that will be just sitting like this and waiting for the, for giving the order. And suppose the 50 person will give the order, so in how many hours the chef will prepare the food and give it back? You can imagine that. So if for eating a food, the 50th person have to wait for 4 to 5 hours. In 4 to 5 hours, he will cook the meal. He will eat the meal and he will sleep also. Okay. So that is what you can do. You can keep multiple employees. It means for multiple processes, you can have multiple separate interpreters in Python. Okay. So that is the concept of multiprocessing. That is the concept of multi-processing. That is all. Yes, that is all. So let's see an example for that and it will be more easy. Okay. So we'll see an example and it will be more easy. So let me show you an example for that. So a very good example is there. But for that, you have to import multiprocessing. And from multiprocessing, you have to import process. So you will write like this. You will say multi. Okay. You have to import multiprocessing. From multiprocessing, you need to import process. Okay. So from multiprocessing, you need to import process. That's all. Okay. Then let's just create a task. Okay. Let's take an input here, parameter, and I'll print. Okay. I'll print simple message. Okay. F string. Okay. Processing. F string processing. And I'll give the name here. That's all. Okay. Now I'll do what? I'll say I will say, I will create for the two processes, I'll create two different processes. So I'll create P1 equals to process target, target equals to task, and I am taking a parameter, so I need to give the parameter. So I'll give the parameter and I'll say task one, comma, okay. Then again, I'll create one more task, one more process, P2, and I'll give here task two, okay. And then I'll do what? Again, P1 dot start p2 dot start, p1 dot join, p2 dot join. So p1 dot start, p2 dot start, p1 dot join, p2 dot join. So let's just quickly change p2, okay, p1, here it will be join, here p2, and here it will be join. Let's just execute this. Okay, what error we are getting? Cannot import name. Okay, I guess I need to install it. Okay. Oh, I have get I've given the wrong name. Okay. I have given underscore here. Underscore will not happen. Okay. It is executed, guys, but we are not getting any message here. I guess what is the problem? I need to get this problem here. Multiprocessing processes, they are creating the process. Okay, it's continuously okay, let me just execute this. Okay, nothing is printed. Why? Maybe it will be because of. Okay, I get it. It is executed, but nothing is printed. This may so happen. Uh, why it is not executing? There could be one possible reason. Okay, people who are using Windows, no, they might need to do this. Okay, they might need to write name equals to. Okay, because you are creating two processes, no, because of that it might so happen. Okay, I'm not so sure. Okay, I'm not so sure, but it may so happen because of this. Okay, so let me now execute this. Now again it is not working. Okay, it's not working again. Okay, let me do what, let me just copy this and I'll go here, here. Let me just try to execute it here. Yeah, I got it, I got it. Okay, so now you see, you get it here. Maybe it is a Jupyter notebook file, no, .ipynb. So because of that, it may so happen that it will be not working. Okay. Okay, guys. So try to execute it in .py extension. Okay. In .py extension, it will work. And I guess it will work without this also. If I'll remove this part, if I'll remove this part, okay, then it will not work. Okay, then it will not work. You have to give this. Okay, you have to give this, then it will work. Wait, Python, Python demo.py. So you see processing task 1 and processing task 2. So it is executed. The import process. No, no, the import process is correct. Everything is correct. There is no problem in anything. The problem is in the file only, the Jupyter Notebook extension. Okay. It in my system it does not work. Maybe in your system it work also. But IPYNB files, no, they are the extensions of the Python file. So because of that, the process related works are not done. Now this was happening with me in my means it's not is today is not something new. It happens with okay, it is a common issue. It happens. Okay, so maybe it could happen with you also. So remember, you are not writing it in the .ipynb files. Okay, because these are the extensions of .py files. The main Python file is .py file only. Okay, so the process related work may be done. It is done in .py extensions only. So because of that, now you can see for this task, okay, what I am doing for task 1 and task 2, what I am doing is I am creating two different processes. Okay. And these two processes are worked simultaneously. These two processes are worked simultaneously. Okay. So this is how you do it. This is what multiprocessing is all about. Okay, guys. So one thing is there, okay, which you guys need to understand about it is what was the thing? I'm just forgetting the topic. What I was talking about. Yes, the underscore. Yeah, yeah. No, no, it's not because of the underscore, my friend. It was because of .py extensions. Because .pynb files are the extension of .py files. Okay, so .ipynb files have different environments. See, it is working on base model. Okay, 3.13. It is Anaconda. Okay, so it processes are mostly found out in the .py extension. That was the reason. Now, guys, I'll go back here and let's see the difference. Okay, the difference I was talking about in multiprocessing, no locking, please. Abdul Malik, in multiprocessing there is locking or not? Yes, yes. In just like the threading, no, just like in threading we do the locking. In multiprocessing also there is locking. Don't worry. There is lock in processing also because multiple process can also use the same file. No, multiple process also can use the same file. So in multiprocessing also there is the concept of locking. Don't worry. Now, guys, let's talk about the difference in thread, okay, versus process. Thread versus process. Now, guys, in thread, we work on the same process. So inside the same process, we work inside the thread. But in process, we have separate processes. Okay, we have separate processes. Then, in thread, we share the same process memory. Okay, but in process, there are separate memory spaces. Okay, remember this. Thread is lightweight, guys. Thread is lightweight. Okay, but whereas the process is more resource more resource heavy. Okay, then uh, thread are thread are a excellent approach. Thread are excellent approach for input and output IO bound work. For input and output work, threads are excellent. Okay, for input and output operations. Whereas processes are useful for CPU bound work. Okay, when you have to use multiple CPUs, multiple memories, multiple processes, then process concept is more used. Okay, in this, communications which we have formed can use shared objects. Okay, but carefully. Whereas here, okay, communications which are formed, okay, they requires a inter process mechanism to use them. Okay, to use them they require a inter process mechanism. Okay, guys, if you want a real world example, okay, guys, if you want a real world example of multiprocessing, so the example could be, suppose, if you have 10,000 images, suppose you have 10,000 images, and each image needs heavy CPU processing. Each image needs heavy CPU processing. So what you can do, you can divide the work. Okay. So what you can do, you can divide the work, and to one CPU core, you can give from image 1 to image 2500. Okay. Suppose you have 10,000 images. Okay. And each image requires a very heavy CPU processing. So what you can do, you can divide the work. You can say that CPU core 1 will handle the images from 1 to 2500. Okay, cpu core 2 handle the images from 2500 01. Okay, 2500 01 to 5000 to 5000. Okay, then cpu core 3 will handle it from 5001 will handle it from 5001 to 7500, and can handle it from CPU core 4 can handle it from 70 7501 to 10,000. Okay, so this is a natural multiprocessing workflow. So naturally means in our systems, in our laptops, in our systems, and in our latest systems, this is the natural flow. This is automatically done. Okay, that's why multiprocessing means lots of work together, means I can execute the Python file also, and simultaneously I am doing the live streaming also. So live streaming is also a separate task in which continuously I am sending my data, I'm sending my screen recording to the YouTube. Okay, and I am executing my Python codes also. I'm writing my Python codes also. I'm executing my Python codes also. So this is what? This is natural multiprocessing workload. Okay. So in this only there is a concept of pool. Yeah. Okay. Sorry for that. Uh, there was some important call. Okay. Uh, so guys, the next concept is about pool. Okay. The next concept is about pool. Okay. Now, what is this pool? How this pool is worked? Okay. I'll tell you. I'll tell you each and everything. So now, guys, what is this pool? This pool is it's kind of a part of a multi-processing only. Let me explain you how. Imagine you have 100 tasks. Imagine you have 100 tasks. Okay, now let's just imagine you have 100 tasks. Okay, and you have only four workers. You have only four workers. Okay, so you don't want to manually create 100 processes. Okay, you don't want to create 100 processes. So instead of that, what you can do, instead of that, you can create one pool. Okay, and you can align your all processes, means you create your pool and you will say I have this many workers. Now all this worker will be automatically managed by that pool. Okay, and the worker will manage the processes automatically, so you don't need to do anything. Are you getting my point? Okay, so instead of creating 100 processes for 100, okay, for 100 tasks, what you can do is you can create a pool, and in that pool you can say that I have four processes. Now that pool will automatically manage all those processes. You don't need to do anything. That pool will manage everything for you. Okay, so let's see that example. So for that example, I'll do what? I'll just comment this example. Okay, I'll go back here and I'll now do what? I will import pool also. So I'll say pool. Okay, so pool is also imported. Now I'll say what? Suppose I have square. I want a function which will do square of a number. Okay, and number. I'll return number into number. Okay, that's all. Now we'll do what? If name. Now this is one thing which we have to write it only. So instead of writing it, I'll just copy this and I'll bring it down here. Okay, and I'll uncomment this. Now I have already this code. I'll say what? I'll give my numbers a list here, and in this list I want to do the square of all the numbers. Okay, okay, and I'll say with pool. Okay, see the style is changing. With pool and processes, I'll mention that I have four workers. I'll mention that I have four workers already with me as pool. So with pool, processes equals to 4 as pool. Okay, and then I'll say results equals to pool dot, okay, Map. I'll use my map function. Map function will do what? It will apply the square method, okay, okay, to this. But remember, we are doing it inside the pool. So pool will automatically manage each and everything. We don't need to do it everything. So how many processes are there? How many workers are there? Four. Now this four workers will do how? We don't need to do anything. Everything will be done. So let's just execute this. So I'll open my terminal. In this terminal, I'll just say python demo.py. Okay, and you see that you get the square of all the numbers. Okay, but this time this square is being done by multiple processes. Okay, this has been done by multiple processes. So this is the concept of pool, guys, that you don't need to do anything. Everything is done by the pool. Okay, so pool does what? In simple language you can say that pool creates a group of worker processes that distributes the task among them automatically. So you need to do it. So instead of creating multiple processes, you can create a pool, and in that pool you will mention that four processes I required it. Now how these four processes and how that task will be distributed to that four processes and five processes, six processes, that depends on the pool. You don't need to do anything. Okay, imagine in the restaurant, if there is the kitchen and you have 10 orders. Okay, you have 10 orders. So now, and you have four chefs. So which chef will deal with which order, that you need to take care of. Okay, there will be a head chef, and head chef will automatically distribute the order. So you don't need to take care of anything. The same concept goes in pools. So instead of creating for 10 tasks, instead of creating 10 processes, you will do what? You will create five process only, and you will just say, okay, that pool, I am creating five workers. Now how and which task will be given to which worker, how many tasks will be given to which worker, okay, that depends on the pool. So that is the concept of pool here. Okay, that is the concept of pool. So this was about pool, guys. Okay, this was about pool. That I'll write it in simple way, that pool create workers. Workers means processes, and manages that how the task how the task will be given to the processes. Okay, automatically it is managed, so you don't need to do anything. Everything is done automatically, so you don't need to do anything at all. Okay, guys, so that is what, okay, processes. Now guys, the next topic which we are going to learn is async. The next topic is, guys, async. What is async? So async is, first of all, you have to understand one thing, okay, that guys, only threads and multiprocessing are not the only way to handle many tasks. Okay, so if you have many tasks, so there is means there is not only threading and multiprocessing which can handle the task is okay. Python also supports asynchronous programming. Python actually supports everything. So Python supports asynchronous programming also. Okay, Python supports asynchronous programming also. So what do you mean by asynchronous programming? Asynchronous programming means that if you have multiple tasks to perform, so you can create multiple async functions, and async functions will do what? They will execute, okay, all the functions at the same time. Okay, guys, so let's do what? Let's see an example of this, okay? Let's see an example of this. And then it will be more clear to us at what I'm trying to say. And then we'll talk more about it, okay? So how you can create a async function? Let me just first give you the example. So first of all, for that, you need to import asyncio. There is a library which is called as asyncio. Okay, asyncio. There is a built-in library, built-in module present. And how you can create a task? So for that, what you can do, you have to use this keyword async. Then you create the normal function. Suppose you want to create a function for greet, so create a function, but write the async keyword first. So it will make this operation as asynchronous operation. It means it will be done automatically. And to execute this function now, you cannot directly just call it. To execute this, now you have to write async io dot, there is a function run, and inside that function run you will write greet. You will execute this, and what it gives us an error that cannot be called running event loop. Okay, okay, so you cannot use it over here. I guess in this it will be used. Okay, so now again you are getting hello only, but it is a asynchronous operation. Let me show you how. Now you can create multiple async functions also. It's not that only you can create one async function, you can create multiple async function. But along with async functions, you get one thing. You get one more thing, that is called as, okay, now I'll not execute here. I'll execute everything here only, okay, in this file only. The next thing which we get is called as await. Now, what is this await? This await also comes with async IO only. Okay, it is also a keyword, and it is used to pause the pause the particular section of the program, okay, until it is not ready. Okay, so till that we can pause the program, and it will not pause the whole program just like time.sleep. No, 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 no. It will do what? It will allow other programs to be executed. So if I'll await one program, so another program can be executed. It's not like that it will stop the whole program. No, 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 no. Let me give you one more example. So in this example only, okay, let me just do what? Okay, this is one function. I'll create async, one more async function, def.task. In this I'll do what? In this I'll first print, okay, I'll first print the task started. Okay, and then I'll say, okay, await await async io dot sleep. Okay, so in async io also there is a function called a sleep, which is used to sleep, pause the task. Okay, then I'll say finished. Okay, and here I'll say task. Now let me show you when I'll execute this now what will happen. Task started, task finished. Till now, any problem, guys? Till now, any topic which you have not understood? So I can repeat it. And if not, so let's start and I'll show you one more example. Now, till now, guys, we are only seeing one function. No, we are only seeing one function. What if we have, suppose I have this greet function also, I have this task function also, and I want to execute both. I want to execute both. So then what will happen? Okay. So to execute it, what we can say is, I have to create one more function. Okay, in one I have used await, in one there is nothing. Okay, and I will do what? I'll create one more async def main function. Inside this main function, I'll do what? I will say await async io dot gather. Okay, now gather I'll use, and in this gather I'll give all my function name. I'll say greet and I'll say task. Okay, now I'll say like this, and then I'll inside run, I'll run my main. Okay, I'll run my main function. And let's now do what? Let's now call python demo.py. So now you'll see hello, task started, task finished. So you see hello and task started are starting at the same time. Okay, let me just again execute this. You see hello and task started are printing at the same time. Then after 2 seconds, task finished we are getting. Okay, so this is asynchronous operation that both the tasks are starting at the same time. Not only that, if I want, I can create, now I can make it task one. Okay, and I can create one more task called as tasks two, and I just need to mention here task one, and I'll give one more task two also. Okay, now you will see when I'll execute the main again. So you will see three tasks will be executed. Hello, task one. Okay, let me just do what? I'll make one more thing. Task two started, task two finished, task one started, and task one finished. Now let me just execute my python demo.py. Now I'll execute my Python. Okay, and before that, let me just make CLS. Like see, hello, task one started, all we are getting together, and then after 2 seconds, task one and task two are finished together. So this is what asynchronous operation means. That it is also gives you a support of multi-processing, multitasking. Okay, it also gives the support of that only. But using asynchronization operations means that at the same time you can start multiple tasks. So at the same time you can start multiple tasks. Okay, so that is what called as asynchronization operation. Okay, that is what is called as asynchronization operation. Okay, guys. So this is all about the today's class, and day 14 is finished. We have learned all the multi-threading, multi-processing, and asynchronization operations, that how you are going to do each and everything, and how you are going to support multi-processing, multitasking. So I hope you guys have understood everything. Okay. So that's all. Okay. So anyone who have not liked the session, okay, please do like the session. Okay. Spyro 12, it is used for flashing pages, right? Yes, it is used in flashing pages, and in Flask also. When I'll show you the project, in that also we'll create async operations, but not in the first project. In the second project, it will be used. Okay, so with web frameworks, with backend development, it is used a lot. Okay, assignment. Yeah, yeah, assignment. Let me just give you the guys the assignment. Okay. So the assignment will our questions are very less, but questions are very interesting and very advanced. So if you'll solve it, so you will get a very good experience of it. Okay. So for the assignment, I need to go here. So this is the first question, guys. Okay. This is the first question, and second question starts from here. Let me just let me just do few settings. Okay, just give me 1 minute. Let me do all the settings here. This is the question for multi processing. This is the question for, okay, question number 6. Okay, and this is for asynchronous operations. Yeah, now it's good. Now let me show you the all the questions. Okay, guys, this is your question number one. Now, Simon sir will practice. Good night. Yes, yes, guys, good night. Take the assignment and then, guys, Spyro 1212 for seeing MD file extensions. Yes, for seeing MD file extensions. This is the question number two. Take a screenshot. Question number three. Take a screenshot. One, two, three, four, five. Okay, I'll wait for 5 seconds. One, two, three, four, five. Okay, next question. Next question is of multiprocessing. You have to square the numbers. Okay, so use a process spool to calculate the square of numbers till 100. Okay, question number six. CPU simulation, create a CPU heavy functions and compare the execution time of normal execution versus multiprocessing. Use the time.time, okay, module and time.pref counter. You can use this one. Okay, don't need to use this one. We have not seen this one, but we have seen this one, so you can use this one. Okay, then for asynchro, there is only one operation. Create three synchronization tasks, task A, B, C. Task A will take 3 seconds, task B will take 1 second, task C will take 2 seconds. Then you have to run all the three tasks using asynchro.gather that we have already seen now. Okay, and observe the total execution time and compare it with running the tasks sequentially. Okay, so that's all the question, guys. Thank you so much, everyone. Extension name. Okay, extension name. Uh, M dot MD something was, yeah, this, which one? I don't remember it. Okay, I don't remember it. Yeah, this, which one is there? No, no, this one is also not there. This one, so I not even installed it. Okay, what are the extensions which I have installed? Auto rename, AU, this one, C hash, CMake tools, Cobalt 2 theme, container tools, CSS Peak, debugger for Java, Devbox, Docker, Docs, OTD. Okay. Now this is for the docs. No, this is not there. It should be something out of this only. Extension pack for Java, Gradle for Java, HTML format, Jupyter. Mm, where live servers there, Magic Python, Markdown. Okay, this one. Okay, this is the extension. This one, Markdown preview enhanced. YY Okay, by YY Okay, this one. Okay, guys. So that's all for today's session. Thank you so much for joining the session. Thank you so much for making the session so much engageful. Thank you so much. Bye bye. Take care. Piyush Kumar signing off. We'll see you in the next one tomorrow. Okay, tomorrow will be the last day of August Python Bootcamp. So, everyone, please join the session. Okay, tomorrow we are going to talk. There is a very beautiful project. Okay, so, okay, we'll see each and every concept. Bye bye, guys. Take care. See you.